Next up is Monister, SVP of Policy and Guidelines at Neilson. David will talk about how they combine advanced meter technology, big data, and people-powered panels into a local TV measurement service to provide in-depth ratings that are representative of what people are actually viewing. As usual, please submit your questions in the Q&A panel that we will go over at the end of the presentation. Over to you, David.
In 1985, there was a movie called Vision Quest, and in that movie there was a wrestler named Loudon Swain, and his goal for that year was to defeat a wrestler that was undefeated, state champion, and he had to drop 2 weight classes in order to do this. So the movie kind of outlines the struggles that he goes through. It's a 1980s movie, so there's a love interest. And in the final scene, he's in the match. There's less than a minute left. It's during a timeout, and Loudon is behind on points. And so his coach asked him, "Have you come here to do everything that you intended to do?" And he said, "Not yet." He says, "Okay, well then do it." And as I saw this, I thought about 3 years ago, I did a presentation for Formulated By, one in Dallas, one in Los Angeles, and I talked about all the things that Neilson was going to do based on tests that we've done with big data. But at that time, we had not done everything that we intended to do. So now here it is, March 2021. In October of 2019, we actually implemented big data based on those tests. And that's what I'm here to talk about today. We call it ratings transformation, and one aspect is the integration of big data. So with that as the backdrop, let's talk a little bit about Neilson. And so the first thing that I want to talk about is the fact that Neilson is known for the television ratings panel. It's a stratified random sample, and based on the fact that we've recruited those households, we know about the demographics of those households. Now, in 2014, we purchased a company named Arbitron that did radio ratings, and part of the assets that we acquired was the portable people meter, or the PPM as we call it. And so we're going to talk about the integration of those 2 panels in many of the markets in which we serve. And then there's big data that's derived from return path data from set-top boxes, whether it's a satellite provider or a cable provider. There's a different set of challenges that come along with this. But I want to talk about Neilson's use of all these assets as a way to increase sample size, to help stabilize ratings, and overall improve the service. Now, one of the things that you need to know about Neilson is that historically, we've used one of 3 meters to collect data. And in the smallest of the markets, 137 lower tiered markets, we used diaries. And this would be a 7-day diary where people would record their television viewing. And as the environment became more complex, the task of keeping a diary became more burdensome. And so we wanted to replace the diary with an electronic measurement. And we're going to talk about that a little later on. But if we focus on the electronic measurement that Neilson has in place, in our top 25 markets, we have local people meters. Now, when we recruit a person to be in a panel, we collect their demographic information. We install a meter that captures or collects the tuning information on all the television sets in the household. And then you have a people meter. Each person is assigned to a button, and when they're in the audience, they log that they're in the audience. And that's what helps us capture the actual viewing of each person in the household. Now, when you have a meter in the household, or whether you're collecting data other ways, tuning actually isn't that difficult. The trick is the who's viewing. And so the people meter really helps us with that. Now, in the 31 set meter markets and the 15 code reader markets, we again are recruiting those households. We've collected the demographic information, and we know the household tuning. But we have to infer the who is viewing, because when you have those 2 pieces of information, what the household is tuned to and the demographics of all the persons in the household, we've developed a technique to extrapolate who's in front of the television set. We're going to talk about that technique in a little bit, as well as the fact that we've leveraged it to use with return path data. Now, if you look at the way we measure today, there are actually 4 different flavors of measurement. The first way is in the top 25 markets, we have the LPM meter. Now, I talked about the fact that we purchased the company Arbitron that had the PPM. And the PPM were in that was in many markets. Anywhere that there was a LPM market and a PPM market, we were able to integrate those two panels. In our set meter markets, there were 19 additional markets that had PPM. But then there were other metered markets, whether it was a set meter or a code reader, where PPM was not available. And so, as a result, we had to introduce return path data. And then in the 137 markets, we phased out the diary. As a result, we installed meters in those markets. And as a supplement to those meters, we introduced the return path data households. So while there are 4 different flavors, we're going to focus on integrating 2 different panels, both Neilson assets. We're going to talk a little bit about that. But where we're really going to spend our time is where Neilson has acquired big data in the form of set-top box data. Those are assets that we don't own, and as a result, there's a lot that we can't control. And what you'll find is that there's a lot of shortcomings associated with that data. But if you're able to correct for those shortcomings, you can make sense of that data, and you can use it for ratings data. So let's move to integrating PPM into television ratings. As I said, we have 2 different panels. Now, the PPM panel, its original intent is to measure radio listening in a marketplace. And radio listening is typically measured in a metro area. Now, television, conversely, is based on a designated market area, or a DMA, which is quite a large geography. So there's the first adjustment that you have to make, is between the different geographies that are being measured. In addition to that, you have to modify some of the edit rules that are associated with radio listening and modify that for television viewing. So we're making adjustments to the editing and crediting rules. To be in the radio panel, you don't necessarily have to have a television set in your house. And about 6% of the households have no television. But to be in the television panel, you have to be a television household. So as a result, we will remove those households. And until next month, we will not include broadband measurement. So if a household has only broadband viewing, which is basically totally streaming, we will not include that in the local sample. That's going to change in April, but to this point, we've excluded those types of homes. Now, one unique aspect of the PPM that's different from our television panel is that, as the name suggests, the portable people meter, it has this meter goes wherever the person goes. So as a result, it has an opportunity to collect out-of-home viewing. In our television panel, we're restricted to viewing in the home, and so this brings an element to the equation that we had not had prior to PPM. So the first thing we have to do is we have to take the out-of-home viewing from the PPM panel, and we have to infer that viewing onto our local TV panel so that we've kind of normalized the 2 panels. Now, the next slide illustrates the fact that you've got a difference in geography. The blue area represents the part of the DMA that's the metro area. And as you can see, there are both PPM homes and television panel homes in the metro. Once you get outside the metro, but still in the DMA, the yellow area represents those TV panel homes. So as a result, you have to adjust for the disproportionate measurement that you have in the metropolitan area. So that's one adjustment that you have to make in order to be able to use those 2 data sets. To do this, we accomplish it through weighting, and we have an initial weight that adjusts for the disproportionate geographic coverage. We then look at the household tuning. We look at the person's viewing. We're able to combine that data. And because of the fact that we've normalized the 2 panels as much as possible, we're able to combine them to generate ratings. So as a result, that's the technique that we use in order to integrate 2 panels. But as I said, both panels are Neilson assets of which we have control over. And we've been able to make the necessary adjustments to make that normalization process pretty easy. But what happens when you have big data that you're purchasing from a third party of which you have no control over? You have to understand that data, you have to understand the shortcomings, and you have to find a way to adjust for those shortcomings in order to make sure that the data is useful. So, let's talk a little bit about the return path data. Now, we implemented return path data into our ratings in two phases. The first phase involved data from the Dish Network, DirecTV, and Charter Cable. We implemented that in October of 2019. The second phase of data dropped in earlier this year, where we included data from Comcast and AT&T U-verse. Now, one of the main things that you need to understand about the set-top box data is that the way the data gets back to the plant is through what's called a back channel. So there's basically two-way communication with the set-top box. Not only are the content providers or the distributors sending content to those boxes so that the viewer can view that content, but data is coming back to the plant that shows the activity that's been on the set-top box. That's called the back channel in which that information comes back. Some of the older boxes don't have a back channel, so just because you have data from any one of these providers, it doesn't mean that you have the data from all of the set-top boxes because of the fact that there may be no back channel. So you have to compensate for that as you start to think about the adjustments that you need to make. In addition to the back channel, you could find that in the data that you have to work with, that there's crediting issues, that the wrong station has been identified because of the way the codes are mapped to the station and the fact that that mapping is changing on a regular basis, or you could have the wrong time because of time-shifted viewing that's taking place. There could be data missing, and one way that that happens is with a phenomenon called dwell time. What that means is that you have to be tuning to a station for a certain number of seconds or minutes before that tuning event registers. Now, the reason for that is that, again, the provider's primary business is to deliver content to their customer. It's not to collect data for ratings or research information for that matter. So as a result, you want to minimize the amount of overhead on your system and minimize the amount of data that's having to be transferred back to the plant. So as a result, some providers may have data in a more granular form than other providers. In addition to that, a lot of people just don't turn the set-top boxes off. So you may turn the television off when you've finished viewing, but you've not turned off the set-top box. And if you were to look at the data associated with that, the set-top box data would lead you to believe that there's still viewing that's taking place when in fact the television is off. Also, there are machine events, which means that there are regular software updates to the set-top boxes, and oftentimes those updates will lead to a false viewing event, which would inflate viewing based on those errant codes that could be interpreted as viewing. So those are just some of the issues with the provider data that we have to compensate for. And in order to compensate for that data, we have a process called Neilson Common Homes. This is where we identify the panel homes that are also in the big data set. We match those homes together, and at a minute-by-minute level, we look for differences in the data, and we come up with an algorithm to correct for those differences. Once we've developed that, we now know how to correct for the data in the remainder of those return path data homes. Each common home solution is unique to that particular provider and is updated on a regular basis. The other purpose that the Neilson panels serve is to be a truth set for big data. So we've already talked about when the set-top box is on, but the television may be off. But you also have a data set that just shows tuning. But you really know nothing about the houses that are associated with those tuning events. So one thing you have to do is determine who's in the home. What's the composition or the demographic makeup of that household? And certainly you can purchase this from a third-party provider, but you have to be aware of the shortcomings associated with that. Now, Remember earlier that I said that once you know what someone is tuning to, and you know the demographics of the household, now you need to determine who's in front of the television and watching that program. Well, we have a technique in order to determine that, and we're going to talk about that in a little bit. And then finally, one of the shortcomings of the data is that it only represents the provider's footprint. And we also know that for the houses that don't have a back channel in their set-top box, that they're not even representative of all their customers. So you have to take into consideration those homes that do not have return path data, or the houses that receive their signal over the air with a normal antenna, and as a result, it's likely that they have fewer channels available to them than those who have a set-top box provider, a cable provider, or a satellite provider, and they could have different viewing behaviors. So as a result, you need to represent those homes as well. Now this is an example, a hypothetical example, the set-top box being on. So in this example, the home is watching a football game from 7 p.m. to 11. They're watching it on the station. They then turn off their television and they go to bed for the night. The next day, they wake up, they turn on the television, they change to a station to watch their local news. If you were to look at the set-top box data, because the set-top box has not been turned off, you would believe that there was a continuous tuning event that took place on that station from 11 p.m. to 7 a.m. By using the Neilson Common Homes, by correcting for these viewing events, you can accurately represent the true tuning events from those that are not taking place, thereby avoiding any tuning inflation. We talked about the fact that you need to know who's in the home. And we also talked about that as being part of a Neilson panel, we collect demographic information. We look at age and gender for ratings data. We also collect a lot of other demographic information. We know the households that have children, the race and ethnicity of the household, and the language spoken. And those three demographic variables are highly predictive in a person's television viewing. We also collect information like education, occupation, marital status. This is all information that we've directly collected from the people in our panel homes. And that then serves as a truth set for us to correct for homes that we don't know the demographic composition. If we were to use a third party to assign those demographic characteristics, the first challenge that you'll see is that just over a quarter of those homes don't have the characteristics that we need to look at the ratings. And then if we were to assign a household, or we use a third party to say, identify households that have a person aged 35 to 54, then we'd be correct just over 70% of the time. And then you counterbalance that by, as you're trying to assign the household size of these homes, that you would have an accuracy rate from as low as 14% for a household size 4+ to as high as just under 50% for a household size of 1. So as a result, there are discrepancies associated with using third-party data, but understanding the Neilson panel data, you can use that as a starting point, and you can then correct for those differences. In this example here, the first column of data shows that the Neilson truth set shows that there are 19% of those homes are Hispanic, 32% are household size 2, and 34% have a presence of kids. If we were to take that data and we were to match by a third-party data set, we would understate Hispanic homes, believing that there's only 13% of the homes are Hispanic. We would understate household size 2, and we would understate households with the presence of children. But if we were to use that as a starting point, take the Neilson truth set, make the appropriate adjustments to the big data set, you can see that the corrected data now comes very close to the truth set in each of those demographic categories. Now, we talked about the fact that if you know who's tuning, or you know the tuning to within a household, and you know the demographics of the household, that you can hopefully get to the viewing. And that's the trick. So we talked about in the homes where we don't have a people meter, we've developed a process called viewer assignment. And this is where we look at the demographic composition of the household, we look at the viewing patterns of the household, and we are then able to infer who in that household is in front of the screen. So we've taken that technique, we've used it in our panels where we have a set meter or a code reader, and we're able to take that same technique and use it for the return path data, because we've taken that data set, we've corrected the tuning events, we've assigned demographics, and now what we're left with is to assign the actual viewing to those households. We also talked about the need for full market coverage, and we accomplished that with our panel, because the homes in our panel that don't have return path data or have only over-the-air measurement are represented in our panel, and there's nothing that the big data set can do to represent those homes. So we're relying on our panel to accurately represent the behavior of those households. When you take all of this together, our intent is to significantly increase the sample size in our panels. Now, before we undertook the big data solution, we looked at bringing our national panel homes into each local market panel, and we were able to increase the sample size by anywhere between 22 and 84 households. That's not a very big sample increase. It barely moves the needle. But by then supplementing it with return path data or big data, we were able to increase the sample size anywhere from 12,000 homes to over 300,000 homes. And that range is dependent on the coverage of the provider in that particular market. By increasing the sample size, we've reduced the number of zero-rated quarter hours, and in the case of the core buying demo, persons 25 to 54, we've reduced zero-rated quarter hours on average 83%, because if you don't have a rating in that quarter hour, then the advertiser's not going to want to purchase advertising in that time slot. In addition, by increasing sample size, you improve the stability of your ratings data. Again, in the core buying demo of persons 25 to 54, on average, you've reduced the standard deviation approximately 6%. We have undertaken two techniques. One is to merge two different panels, normalize those panels, and in the process, increase sample size. We've done the same thing in our other markets by using return path data. In both cases, the objective is to increase sample size in order to reduce zero-rated quarter hours and to improve the stability of our ratings. Neilson will continue to look at ways in which we can increase that sample size to continue to improve the quality of our panels. So at this point, I think we'll go over to questions.
Great, thanks so much, Danny. We do have time for one quick question from the audience. Do you find a bias in the household demographics willing to be recruited?
So that question deals with what we call non-response bias in the research world, and there are two ways that you can address that. The first way is that if you have a very high response rate, because the Neilson panel is based on all of the census blocks in the U.S., we use a stratified random sample to then select those respondents. And if 100% of those respondents were to cooperate, then theoretically we'd have an exact representation of the U.S. With that sample. Our response rate right now is about 30%, one of the highest of the methodologies out there. Now, because of COVID, we've taken about a 5% hit. So prior to COVID, that response rate was higher. Now that we're coming out of COVID, we expect that response rate to go back up. And so as a result, you'll have an opportunity to better represent the marketplace through response rate. Now, in addition to that, we look at the census distributions of various age, gender, characteristics. We look at things like presence of children and geographic distribution as well. We then look at those census breaks relative to our return sample, and what we can see is that we are within sampling error of representing those particular groups. So that's another sign, well-balanced panel that doesn't have a lot of bias introduced into it. And then we use weighting to correct for any of those biases that may exist. So there are several techniques that we have in place in order to compensate for that.
Great. Well, thanks so much. This has been a wonderful presentation. And everybody, we're going to take about a 15-minute break, but we will meet you over in the next session with Carlos from CAA, and we'll see you there.